Hello all, today we'll be doing a project which is called as Credit Card Anomaly Detection. This is a wonderful data set that is actually present in the Kaggle website. So I've taken up this data set and I've actually implemented the anomaly detection basically to detect whether there is any fraudulent transaction with the help of a credit card. So the context of this particular problem is all about credit card fraud detection. Now, over here, let us just read the context. It is important that credit card companies are able to recognize fraudulent credit card transactions so that the customer are not charged for items they did not purchase. So this data set that you have will be, this is the data set and you can read the details from this content. Let me just tell you some of the information about this particular data set. It contains only numerical inputs which are the result of PCA transformation. See, they have done the PCA transformation of the already done transaction data, and the reason they have done the PCA transformation is that because this data is very very important and it cannot be shared just like that. You can see over here, unfortunately, due to confidentiality issues, we cannot provide the original features and more background information about the data. So what they have done is that they just transformed that variables, created new features and new features like V1, V2 till V28. They all are the principal component values with the help of PCA basically. And there is also some features that are basically dependent cost sensing learnings. Feature classing, the class is basically the response variable, which is basically the output, and it is having 1 in the case of fraud. Otherwise, if it is not 1, it is not fraud. Apart from this, there are some more information from where the data set is actually collected, and these are basically the website. You can just go to this particular link and actually have more details about discussion about this particular data set. So first of all, what we will do is that in order to apply anomaly detection, I'm going to use some techniques which is called as isolation forest algorithm and local outlier factor algorithms. From both of these, isolation forest algorithm has worked pretty much well, and the accuracy is much more better than local outlier factor. So we'll discuss about these two techniques. Make sure you watch this video till the end. So initially, I'm just going to import all this particular library which I'm basically using. I'm also importing SVM because with the help of SVM also I'm trying to find out how many outliers are there. And this is a completely imbalanced data set. I'll just show you guys. And even though it is an imbalanced data set, this isolation forest and local outlier factor has worked very, very nicely, and we are able to get the exact right kind of output that we actually require. So initially, as usual, we'll be reading the data set, which is called as creditcard.csv. After that, we are just going to read the head part. Now here you have something like time variable. Apart from that, you have the class variable. Class variable basically 0 indicates. Here you can see over here, the description of the data set says that if the value is 1, it is basically the fraud. If the value is 0, it is not a fraud and it is a normal transaction. So most of the data that you will be basically seeing over here is basically having zeros. How I'm seeing that is just because of some feature engineering. So I'm just doing data.info and seeing some information about this particular data set. And I'm just trying to check whether there is any null values as a part of my exploratory data analysis. There are no null values. Apart from this, what I'm doing is that I'm trying to find out how many number of classes are basically there, and with respect to that, frequency is there. And here I come to know that normal transaction are more than 25,000. Sorry, it is not like it is more than 250,000 records, whereas fraudulent transaction is very very less. You can see that just a small arrow line that you see over here. It is very very small amount of fraudulent transaction. Now, after seeing this, you can definitely see that it is an imbalanced data set. I'm not taking this imbalanced data set. Instead, I'm just directly applying algorithms like isolation forest algorithm and local outlier algorithm to basically solve this particular issue. So what I'm doing is that wherever the value is 1, I'm taking it as a fraud data set, and normal data set I'm taking it as 0. This is just a condition. Then I'm just seeing the shape over here. You can see that only 492 records are actually having fraud, and normal records are more than 250,000 records itself. Then fraudulent amount description, we are just seeing to understand some more information, and this is what it is basically having. This basically helps you to see like what amount of transaction, like if you're doing some transaction, how much amount that particular mean value was there for fraud data set and fraud transaction. Similarly, for normal transaction, what was the value? Then after this, I'm also seeing, I'm using matplotlib, okay, a lot of matplotlib and cbon, and trying to see how was the transaction OFC. You can see for fraud transaction, the transaction were with respect to the amount, right? The dollars amount. It was very small transaction. But whereas in the case of normal transaction, you have huge amounts, not only smaller amounts, but fraudulent transaction was mainly smaller amounts that you see from this particular graph. And this is the code. Don't worry about this code. I'll already provide this particular code in my GitHub. You can download it and you can start exploring it. And this is just by using some matplotlib, and I'm just printing the fraud amounts and the normal amounts in the terms of histogram. And it's simple. It's quite simple. And this information basically says that the transaction amount is very small for fraud data set. Okay. After seeing that, I'm also trying to see that how many different transactions are there for the fraud in terms of time. Okay, now you can see that there are a lot of fraud transactions with respect to time, and these are normal transactions. By this, we cannot explore too much. So I've just drawn this particular diagram as a part of feature engineering. Then what I do is that instead of taking the whole sample, whole data, I'm just taking a data sample, because the reason I'm taking it as a sample, because it will take more time for pre-processing, because there is a huge data set. It has more than 280,000. But in your case, if you want to basically apply just local outlier algorithms and all, you just take a small data set. I'm just taking a fraction of 0.1% of the whole data set. And this is what the shape. Now I just have 28,000 records. You can take the whole amount, but again, I can't just directly show it over here because it will take a lot of execution time. What I can do is that then from this, I'm trying to determine how many are fraud, how many are valid from data one. Then I'm just taking the outlier fractions. So I have this fraud cases as 492, 49 and 28432. Okay. Apart from that, I can also do correlation and try to find out like how all the features are with respect to the class variable. And they are different colors that have come out. You can go through this correlation. They are having some positive and negative values also. Then I create the independent and dependent features because I need to apply the model. See guys, I'm not handling the imbalanced data set, okay? The imbalanced data set will already be taken care by the algorithms that I'm going to use. That is local outlier and all, isolation forest and local outlier. So here what I'm doing, this is my X basically will be giving my independent features. Y will basically be giving my dependent features. I've just written a smaller condition saying that wherever the column name is not having class, just consider that as my dependent features. Otherwise, whichever are having the class, just consider that as my dependent. For wherever there is no class as my column name, take it as my independent features. Wherever there is a class, take it as my dependent features. So here X and Y is basically created. And I'm just seeing the shape over here. Finally, model prediction, simple isolation algorithm, forest algorithm. So let us just discuss about how isolation forest algorithm will be working on. Okay, and this isolation forest algorithm completely unique of random forest. Okay, so if you know random forest, I think you will not find much problem in understanding how does this basically work and how is the working of isolation forest algorithm. Always remember, whenever you have an outlier, right, in your data set, right, in that case, you can also read it from here. I've given a lot of techniques over here. The main thing is basically to understand how isolation forest works. Okay, over here. Now you can see that the isolation forest work, the isolation forest algorithm isolates observation by randomly selecting a feature and then randomly selecting a split value between the maxima and minima splits of the selected feature. The logic argument goes, because of only a few conditions are needed to separate those cases as the normal observation. Let me just provide you a brief scenario how isolation algorithm works. Now, I hope everybody remembers random forest, right? We'll be doing a lot of split. Now, random forest uses multiple decision tree, okay? Multiple decision tree, and the division will be going on like this. And this is with respect to, suppose this is my decision tree 1. Similarly, I'll be having decision tree 2, 3, 4, and any number of decision trees. Now, isolation forest also works. But in decision tree, the isolation forest also makes this kind of trees, okay, internally, and many number of trees. And for each and every split along with the leaf node, along with the leaf node, sorry, not this, along with this leaf node, right? It provides some value, and that value or some, it is just like, it'll select some value for this leaf node, which will indicate which will indicate that based on the number of depth I go, okay, based on the number of depth I go, that value will be increasing. Okay, let me just consider score. Some score value will be there. Okay, now as the splitting goes on, as the splitting goes on, as the splitting goes on along with the depth, right? So this score value will be increasing for the leaf nodes. Okay, but suppose if we have an outlier, remember outlier is, okay, outlier is a value which will not be actually nearer to the other values that I have in this leaf node. It will be completely separated. Now see, suppose if I have some data set which is populated densely, okay, populated densely. Now suppose I have some data over here. So this data is basically an outlier because all the other data set is populated densely over here. Whereas in this case of, so whenever I try to use this particular data set and start dividing my random forest decision tree, at that time, these all values will be populated or it will be splitted quickly. Okay, when it will be splitted quickly, this score will be assigned a lower value. But in this case, these all values will be divided more and more and we'll be getting different leaf node. Okay, and the score value increases for this. Okay, so understand that why this particular algorithm works, because when it is creating a decision tree, right? When it is creating a decision tree, the outliers will be splitted initially at the initial depth itself, because the outlier is a completely different value. So the root node will be selected in such a way that the outlier will be splitted. Like suppose all the values are over here less than 100. Suppose I'm just taking, okay, this example as less than, and there are some outliers, right, which is greater than 100. Okay, now if my root nodes gets divided, one will be less than 100. So all my data points will come over here, which are my valid data points, right, will be coming over here. Whereas in the case of outliers, which will be very, very rare, very, very less number of values will be getting splitted. Now this particular score will be much more lesser than the assigned score over here, because this all are, the depth is basically increasing. In this case, the outlier is rare, the depth will be less, you know, the split will quickly get this leaf node, so the score will be less. Now based on this particular score, it will directly understand that these are my outliers, you know, and then it will be able to understand how many error points are there, how many outliers are there. So this was the basic understanding of isolation algorithm. So isolation algorithm completely works on an anomaly score. I was just talking about this anomaly score. Here you can see, I'll just read down this, okay. The isolation forest algorithm isolates observation by randomly selecting a feature and then randomly selecting a split value between maximum minimum values of the selected feature. The logic argument goes, isolating anomaly observation is easier because only a few conditions are needed to separate those cases from the normal observation. Because as I said that our outlier will be very rare. So whenever decision trees are basically used by using a random forest on an isolation forest, this will be, you know, these cases will be basically, it can be very, very easily separated from the normal observation. That is what you have to note. Again, I'm repeating this point. The logic argument goes, in isolating anomaly observation is easier because only a few conditions are needed to separate those cases from the normal observation. Because the outliers are very rare, it will be separated very easily on the other hand. Okay. Whereas on the other hand, isolating normal observation require more conditions, multiple if-else loops. You know, that is what decision tree basically uses, multiple if-else loops. So this will basically take time, and the score that will be getting assigned, it will be based on the number of conditions required to separate given observation. That is basically my leaf. Okay. So that is how an isolation algorithm works. There is also a different technique which is called as local outlier factor. What I did for this particular problem statement, I have tried both isolation forest algorithm and local outlier factor algorithm. Okay. Now this particular thing works with, it computes the local density deviation at a given data point with respect to its neighbor. It considers that outlier samples that have a substantially lower density. So suppose my data set has higher density over here, okay, then it will consider this as normal observation. Suppose it has lower density somewhere like this, then this will get treated as my outliers. So that is the clear phenomenon between the difference between isolation algorithm and isolation forest algorithm and local outlier factor. So let us just go and try to implement it. Now here I'm creating a dictionary. For my isolation forest, I've told that I have to use n_estimator, which is my decision tree of 100. How many samples I have to use, all this information is basically given. For the local outlier factor, I have to say that please consider n neighbors as 20. So suppose if the density is more than 20 neighbors, or it is still 20 neighbors, it will be considered as, you know, greater than 20, greater than or equal to 20, then it will be considered basically as a normal observation. If it is less than 20, then that will be basically considered as, you know, and this is considered for a huge data set, guys. As the data set size changes, this value may change. Okay. Now here we are basically using the Minkowski metric in support vector machine. This just to understand. I'm also showing you a support vector machine. So here I've just created a dictionary. You'll be seeing that this too will be outperforming the SVM that I'm basically using for separating the outliers, because SVM, it completely works on you know, making a decision boundary between the points. And I've also created a video on that. You can go and have a look. So here you can see, as soon as I executed the classifier, this is my dictionary type. And then I'm just putting a for loop and applying fit predict on X. Okay, fit predict on X. By this, I'm getting my Y predict. That's it. Now you can see similarly for local outlier factor, support vector machine, for, and this is my else block, which is my for all these functionalities I'm actually checking. For all these algorithms I'm checking, and then I'm printing my accuracy score, my classification report. Now here you can see for isolation forest, I have got 73 error points. That basically means it has determined 73 outliers. Okay. The accuracy score is 0.997 while determining the outliers. And apart from that, you can also see for local outlier, it has predicted 97 errors, 97 outliers or anomalies, you know. So similarly, you can see support vector machine is, it's you know, finding 8,516 outliers, which is actually, again, as I said you that isolation forest is outperforming both local outlier and the SVM. So this is my observation that we found out from this particular notebook file, is that this particular execution, that isolation forest detected 73 error values versus local outlier factor, which is detecting 97 errors, versus SVM detecting 8516 errors. Now this is a huge number. Okay. Now isolation forest has a 99.74 more accurate than LOF, which is my local outlier factor of 99.65, and SVM here it is only giving me 70%. You can see over here. The accuracy score is only 70% to correctly determine whether it is an outlier or not. Okay, now that outlier is basically like it is able to determine whether it is fraudulent or not. The reason why it is not performing, because first of all, your data set is not balanced. Okay, and that imbalanced data set may work well with isolation forest and local outlier factor. So because of that, it is very, very clear that the imbalanced data set is being handled properly, and there is only something like 73 errors, whereas in case of local outlier factors, it is 97 errors. Then apart from that, you can also see all the other observations that I have noted over here. Just download this particular notebook file, you'll be able to do it. Do it, guys, because this is the project many people were asking for. That is an anomaly detection. You have to detect whether the transaction is basically fraudulent or not based on a data set that you have. So I hope you like this particular videos, guys. Make sure you subscribe the channel. Keep sharing, share with all your friends, whoever require this kind of help. I'll see you all in the next video. Have a great day ahead. God bless you all. Thank you, one and all.